Students, today we are going to learn Science Chapter 4 Current, Electricity and Magnetism. Let us see the main points. First, electric current. It is the electric charge flowing through a conductor such as a metal wire per unit. Its SI unit is the ampere. Electric current is a scalar quantity. Now, what is electrostatic potential? The electric level deciding the direction of flow of electric charge is called electrostatic potential. Its unit is the volt. Electrostatic potential is a scalar quantity. What is meant by potential difference? Potential difference. It is the difference between the potentials of 2 points. Dry cell, lead cell, NICD cell and sources of electricity. Electric circuit. A continuous path consists of conducting wires, a switch or a plug, key and other resistance between the terminals of a cell along which an electric current flows called an electric circuit. To obtain more potential, different cells are connected in series. Now, what does it mean by electromagnet? Electromagnet. If a coil is wound around an iron screw, the screw behaves as a magnet as long as there is current in the coil. The system of the coil and the screw is called electromagnet. It is an example of magnetic effect of electric current. The working of an electric bell is based on the magnetic effect of electric current. Let us see and discuss about the figures which are given in the chapter. Let us discuss about figure 1. Take connecting copper wires and connect the circuit as shown in the figure 4.1. No current is seen to flow in the bulb. Now connect in the same circuit a 1.5 volt dry cell available in the market. Now it will be realized from glowing of the bulb that current is flowing in the circuit. Electrons in the wire flow due to the potential difference between the two ends of the dry cell. This flow from the negative terminal of the cell to the positive terminal of the cell. Conventional current flows in the opposite direction and is shown in the figure by the sign of an arrow. We will learn about an electric circuit later in this chapter. Now, in figure 4.1, there is no current as there is no potential difference in the absence of any cell. Current starts flowing in the circuit as soon as the potential difference is applied. The unit of potential difference in SI system is the volt. We will learn about it in the next standard. Now, let us see what is given in figure 4.2. Now, in 4.2, the figure of dry cell is shown. Take a lead dry cell and remove its outer coating. Inside, you will find a whitish metal layer. This is the zinc metal layer. This is the negative terminal of the cell. Now carefully break open this layer. There is another layer inside. An electrolyte is filled between these two layers. The electrolyte contains negatively charged and positively charged ions. These are the carriers of electricity. The electrolyte is a wet pulp of zinc chloride and ammonium chloride. There is a graphite rod at the center of the cell. This is positive terminal of the cell. A paste of manganese dioxide is filled outside the rod. Because of the chemical reaction of all these chemicals, electrical charge is produced on the two terminals and an electric current flows in the circuit. Due to the wet pulp used in this cell, the chemical reactions proceed very slowly. Hence, a large electric current cannot be obtained from this. Compared to the electric cells using liquids, the shelf life of dry cells is longer. Dry cells are very convenient to use as this can be held in any direction with respect to ground and can be used in mobile instruments such as radio sets, wall clocks and torches. Now let us discuss what is given in figure 4.3. In figure 4.3, the lead cell is shown. The lead acid cell contains two electrodes, Pb and PbO2, dipped in dilute H2SO4. Chemical reaction between the substances in the cell produces electric charges on the electrodes. PbO2 carries a positive charge and Pb carries a negative charge. The potential difference between the electrodes is nearly 2 volts. If a load such as a bulb is connected externally between the two electrodes, an electric current flows through it. It can deliver a large current. This cell can be recharged after getting electrically charged. Now let us discuss about the figure 4.4. When the key is open, there is no current in the circuit, hence the bulb does not glow, which is shown in figure 4.4. It is a figure of simple electric circuit. When the key is closed, a current flows in the circuit, hence the bulb glows. Now figure 4.5 is given as reference. Here 4 cells can be connected in series to obtain more potential differences. Now let us discuss about the figure 4.6. Now in this figure 4.6 activity is given. It shows magnetic effect of electric current. Take the inside tray of a used up matchbox. Place a small magnetic needle inside the tray. Now take a long connecting wire and wind it around the tray. Complete the electric circuit by connecting in it this wire, electric cell, plug, key and a bulb as shown in the figure. Mark the position of the magnetic needle. Take a bar magnet near to the magnetic needle. Now what you will observe? You know that a magnetic needle is indeed a magnet. You have seen that the magnetic needle changes its direction when a bar magnet is taken near the magnetic needle. Also, you have observed that the magnetic needle changes its direction when a current starts flowing in the circuit. This means that magnetic field is created when an electric current flows in a wire. Hence, Christian Ørsted made this observation first. Briefly, we can say that when an electric current passes through a wire, a magnetic field is produced around the wire. Now, see the figure 4.7. It is a figure of electromagnet. When the electric current flows in the wire, magnetism is produced in the coil around the screw, and because of that the screw also attains magnetism. As soon as the current is stopped, this magnetism vanishes. The system of the coil and the screw is called an electromagnet. You have seen various uses of the electromagnet in the 6th standard. Electromagnets are used to produce a strong magnetic field useful in scientific research. Now, let us discuss about the figure 4.8. The figure 4.8, it shows electric bell. The construction of the electric bell and also the electric circuit. The bell consists of an electromagnet, contact, screw, iron strip, metal striker and metal gong. A coil of copper wire wound around an iron piece works as an electromagnet, and an iron strip along with a striker is fitted near it. A contact screw touches the stripe. The circuit is closed with the key. The current flows in the circuit when the screw is connected with the iron strip. The current carrying coil becomes a magnet and attracts the iron strip towards it. As a result, the metal striker hits the metal gong, producing sound. At the same time, the screw loses the contact with the strip. The circuit is now incomplete. Hence, no current flows in the circuit. Therefore, the electromagnet loses its magnetism and the electric iron strip returns to its initial condition, making contact with the screw. As the circuit is now completed, the electromagnet attracts the iron strip and the striker strikes the gong, producing sound. The action repeats itself and the bell continues to ring till the circuit is broken by opening the key in the circuit. The working of electric bell is thus based on the magnetic effect of electric current. So, let us see what we have learned in this current electricity chapter. Electric potential, the volt. Current 1A is equal to 1C by S. Dry cell, lead acid cell, NiCd cell, lithium ion cell. Series arrangement of cells to obtain more potential difference. And magnetic effect of electric current, electromagnet and electric bell.